Okay, so we're back, and now let's look at, we're just going to look at the first two examples and see. And I think within here, I'll have some quiz questions to see whether you are good or not. Okay, so what I'll do is we'll go over ABC together, and then I'll ask you questions about D and E. Okay, so which of the following are binomial experiments or can be reduced to binomial experiments, right? And so again, you can go back over those 4 requirements, a fixed number of trials, right, done. Each trial can have only 2 outcomes or outcomes that can be reduced to 2 outcomes, okay? And these outcomes we consider as success or failure. The outcomes of each trial must be independent of one another, and the probability of a success must remain the same for each trial, okay? So let's look at, let's see. I think I'm going to do in between. So let's look at A. So A, testing one brand of aspirin by using 10 people, okay, to determine whether it's effective, right? Do you think this is binomial? Okay. It is, right? It is binomial. It satisfies those 4 requirements. And the one thing you want to think about in determining, look over those 4 trials, but if it's not clear, make sure it's clear what your 2 outcomes are. Okay, you should be able to list your 2 outcomes, or think about how the 2 outcomes may be listed, I should say, because it could be various ways you list 2 outcomes. In the case of A, if you want to know whether people consider it effective or not, you would have your 2 categories would be effective, or your 2 outcomes then would be effective versus non-effective. Okay. I'll quiz you on B. Let's look at C. Checking 1,000 applicants to see whether they were admitted to White Oak College. You think it's binomial? Yes, it's binomial. Okay. And in fact, you may want to just pause the video and see if you can answer whether it's binomial or not. Okay. C. So it's binomial because this could be a yes or no type of outcome, right? You have 1,000 applicants and you just ask them, were you admitted to White Oak College, yes or no? And there you have your binomial experiment. Okay. Let's look at D together. Surveying 300 prisoners to see how many different crimes they were convicted of. No, that is not binomial, right? Because there's not, in terms of putting it in 2 outcomes, right? That would be difficult and especially since you want to see how many different crimes, right? So you want to categorize the different crimes, and you can't, of course, you wouldn't be under the assumption there are only 2 different crimes, right? There are multiple types of crimes, so it's not binomial, okay? And E, I will leave as a quiz question. Okay, now looking at example 2. So here you will need to use table B. Now I have uploaded various tables in Moodle, or they will be uploaded before Monday, and or before you watch this video, I'll make sure I upload them. But the table B in Appendix A, so it's in your book, but I wanted to have you to have it handy. We'll be using various tables. If you have a printer wherever you are and can print out the tables, that would be most effective, because when you're doing quizzes and stuff like that, if you don't and you're not able to print them out, then we'll need to figure something out in regards to, like, for exams and quizzes, how that will work. But just let me know if that's the case. However, so here, the table B, and so I've uploaded table B. It's going to look something like this. It may look a little different than this, but basically, if we look here, so looking at A, it says compute the probability of X successes using table B in Appendix A. Before we do look at the table, though, I want to go back to our binomial probability formula, which is P of x equals n factorial over n minus x factorial times x factorial times p to the x. And I'm actually going to keep it separated, times q to the n minus x. This formula you can always use instead of the table. The table is there to just help simplify your life a little bit, but let's use this formula so you can see how it's being used, and then we'll check it with the table. So let's see. So P of x, so n is 2, right? So what we have, x is 1. So we're going to have P of 1 equals 2 factorial, right? All over n is 2 minus 1 factorial times 1 factorial, right? Because that's that x factorial, times P is 0.30. I'm just going to use, well, I don't want the factorials. I'll use this time. Oh, no. I think that messes it up more with the letters. So we'll just we'll keep it there. Times P is 0.30. X is 1, so to the first, times P minus Q. Well, if P is 0.30, Q is 1 minus P, right? So that's 1 minus 0.30, which is 0.70. So times 0.70 to the first power, right? Because it's n. Well, let me make sure you guys are clear where I get the first power. N is 2, so it's 2 minus 1. Okay. And in terms of, if you're unclear on where these values are coming from, so here's the direct correlation, right, to everything. Okay. And so let's simplify this. So P of 1 equals, well, 2 factorial, that's 2 times 1, right? So that's just 2. Okay, I hope you're clear on that. And then 2 minus 1 factorial is 1 factorial. But remember from our convention, 1 factorial is just 1, right? And then times 1 factorial again times 1. And then times 0.30, because that's just the first power, times 0.70. So in essence, what we really have here is 2 times 0.30 times 0.70. Okay? And if you calculate that, you will get 0.42. Okay. Well, let's see if that matches up in our table. Okay. And again, while you're looking at these videos, if there are any questions you have, make sure you write them down and you can ask them. Feel free to ask them in class. All right. So let's look at this table. Well, again, n is, let me write down what we're looking at. So for A, n is 2, P is 0.30, and what else? And X is 1. So if we look at this table, that categories are n, so n is 2, right? And, oh, this is, R is actually X. So in the notes that I gave you, the binomial distribution is X instead of R, okay? So it's actually X. But X is 1, right? So we're looking here at this row, and then P is 0.30. And if you look there, we see we have our 0.42. Okay, so you can always use the formula, but because of time and things, if we're taking something that's like a quiz or something that's timed an exam, this table will be more useful than having to use that formula. This wasn't too bad because the number was sort of small, but if we look at these other numbers, then it can be a little more complicated. So let's now look at B and C with the table, and then D and E I'll have you look at on your own. Okay, and again, if you have questions, just make sure you write them down. Okay, so B, let's see, N is 4. So I'm going to erase this now, and we now know that this is X. All right. So for B, N is 4. What else? It's 0.60 and 3. P is 0.60 and X is 3. All right, so N is 4, so we're here. And let's see, what else do we have? N is 4, P is X is 3. Let's go to X first. and then 0.60. So what do we have? 0.346. You guys should have that. So B is 0.346. Okay. And then for C, let's see, N is 10. Okay, so in fact, N is 5, P is 0.10, and X is 0 for C. And so we go here, 5, X is 0, and 0.10. So 0.590 for C. All right, quiz time.